There you go, Daniel. A little Illuminati X-Files song to start your day. Let's talk about what we need to know from yesterday's geometry video and what we're going to do for tomorrow's class. A lot of review. So by now, after the first class, you should know that for any n-gon that is convex. What a convex polygon is any polygon where if you extend the edges of the polygon, they are completely outside the polygon's region. So if you extend the edges, here is an example of a concave polygon. If I extend this edge, it intersects the interior of the polygon. Not beautiful drawings, but for a convex n-gon, the sum of all the interior angles, there's n of them, right? For however many sides, there's n angles. The sum of the interior angles can be found by taking 180 times n minus 2. And if it's a regular or equiangular polygon, then you know you can take that sum and divide it by the number of angles. Good? Same idea if you know all the exterior angles add up to 360 degrees for any n-gon. If it is regular or equiangular, then you know 360 divided by n is one exterior angle. So I wrote that on the board. Make sure you have it in your notes. Make sure you understand it. To understand it, take any n polygon, right? And who cares how many sides there are, right? So this is some n-sided polygon. Take one vertex, right? Call this point 1. Then this is 2, this is 3, this is 4, this is 5, all the way around. This is n minus 2, this is n minus 1. I'll just put one here to bug Nelson, and this is n. There are exactly n points around this polygon. Now if I start drawing the diagonal, these two don't count as a diagonal. They're right next to each other. But there are as many diagonals from 1, right, going to all of these points as 2 minus the points. Not this point and this point. So that's where the n minus 2 comes from. That for any n-sided shape, you can create exactly n minus 2 triangles. And then if you multiply that by 180, because we know the interior angles of a triangle add up to 180. So you got to be able to use those. Again, just to put it in a video so I can say you're responsible, you've got to know that a triangle is 3 sides. A quadrilateral, this is really important, we call 4-sided figures quadrilaterals. There are lots of quadrilaterals, and that's what we're going to study the rest of this unit. We're going to study parallelograms. We're going to study rectangles and squares and rhombi and kites and trapezoids. But the whole family of them is quadrilaterals. And then pentagon. For 6, we have hexagon. For 7, don't forget, it's Greek. We have heptagon. 8, we have octagon. 9, we have nonagon. 10, we have decagon. 11, undecagon. And then lastly, 12, dodecagon. Anything bigger than 12, 13 plus, we will just use the number dash gon. So 23-sided is a 23-gon. There are some other names, but we're not going to worry about them. Now, moving on to the next section for tonight, we're going to talk about parallelograms. It's really important that we define these terms as narrowly as possible Because if we can make our definition narrow and then prove properties about it based on that definition, then it's just a better system, right? So I could tell you parallelograms have congruent sides. I could tell you parallelograms have opposite angles are congruent. I could tell you that parallelograms have consecutive angles that are supplementary. Or I could tell you parallelograms have diagonals that bisect each other. But all of those properties can be proved if we just define a parallelogram as a quadrilateral, so that's four-sided figure, with both pairs of opposite sides parallel. So if you know something is a parallelogram, then all you know is that QR is parallel to PS and SR is parallel to PQ. So from that simple definition, we can get four very important theorems. One, that the opposite sides are congruent. Two, that the opposite angles are congruent. Three, that the consecutive angles are supplementary, so x and y and x are supplementary. And lastly, that the diagonals bisect each other. Your homework tonight is to prove these four theorems. If they are written down in a two-column proof, tomorrow you will get 10 points. If they are not proven, tomorrow at 8 a.m. for second period, 10:25 for third period. If they are not written down at that time, you will get 0 out of 10 and no chance to make it up. So some things that you might use in these proofs to make them easier. You might say between any 2 points there exists a line and introduce a diagonal. You might do the same here, except you might have to do this and say between any 2 points there's a diagonal, prove that P and R are the same, and then do a second proof where you introduce this diagonal and you prove that Q and S are the same. Should go pretty fast, and the step for that is introduce segment PR because between any 2 points there exists a line. Don't forget if parallel AIA supplement or CIA supplementary, because I think that one is all you need to prove these. And then lastly, introduce these two diagonals and use anything that you've proven before. So you may know that opposite sides are congruent, and then here you may know some vertical angles, right? You may have this big triangle and then look at this triangle and like go, I've got this angle congruent to this angle. I've got a shared side. I've got, some things to look at there. So bisect each other, that one's hard. You have to prove that this segment is congruent to this segment. You have to prove that this segment is congruent to that segment. Then you have to say the measures are equal because the segments are congruent, and then you can say they bisect each other. So if parallelogram, then bisect each other. Notice that those red marks are not a given. So that's it, short video. Daniel, I hope you enjoyed the music because now you got to do some proofs. Peace.